Assalamualaikum warahmatullahi wabarakatuh. So, uh, in previous topic, we have discussed in detail the mass moment of inertia, how we get it, how we obtain it, calculating from the basic equation of mass moment of inertia, and uh, how you refer to table to calculate the mass moment inertia and parallel axis theorem. But in this subtopic, we have to go to what we call it planar kinetic equation of motion. I believe that in static you familiar with this equation summation of force is equal to ma. This is a Newton's second law, and but in static basically when a is zero, sorry, when when a is zero, you can say that the summation of force is equal to zero. All right, same equation used in this topic, and then basically we still use this equation. Summation of force is equal to ma, and a basically you write ma only, but basically e is normally referred to a at g. The acceleration refer to g, the center of gravity. Basically this is the right way to write the summation of force lah. Summation of force is ma g. Even g, let's say this rigid body accelerate or move to top left, this corner, so we can split into two. This is a, so g, you can have a g y, you can have another one a g x. So basically summation of force in x, you write it as a m a g in x, and summation of force in y is m a g y. Easy, right? So summation in it. So even for force, for the example, if you take the force one, you can split into f1 x and f1 y. Then you can solve the equation of, you can solve the problems. Okay. And then for equation of rotational motion, we are talking about rotational motion. What is the equation involved? But for any problems, it can be combined. You have to use both equation from equation of rotational motion and equation of translational motion to solve the problem. All right. Let's say you have similar bodies here. You have force 1, external forces, force 2, force 3, force 4. You have external moment m1 and m2. And then you have weight, weight for the example. And then you have the center of gravity, which is at point P. And then you have the global coordinate system, and its reference is at P. Alright, we know that this moment, equation of moment is R times F. If we say the summation of moment is summation of R, let's say I equal to 1 I times Fi. Alright, for rotational motion, if you see page 410, there is a complete derivation of how you can get the equation of moment. So basically the summation of moment is written as summation of moment. If the moment is rotate about g, for the example, is rotate about g, so it's equal to the mass moment of inertia for the body at g times alpha. Alright, so we can put here summation of moment is summation of I equal to 1 for Ri times F1 I plus summation of moment. Summation of moment. For this case, we have two moment, M1 and M2. So summation of M1 plus summation of M1 and M2. So equal to IG times alpha. Alright, easy, right? Okay. Okay, instead of referring to point G, here you are referring to point G, the center of gravity. So the equation is very easy. So you can straight away on your left hand side, sorry, on your right hand side, Ig times alpha. No additional term here. No. But in some cases, in some problem, basically, if you want to use the equation, the summation of moment, if you refer to point G, sometimes it doesn't solve the problem, because there are few unknowns that cannot be solved. So instead of summation of moment at point G, you can say that you can choose any point. You can choose any point on the rigid body or some out of the rigid body, but you have to know the distance. Okay, you can put the summation of moment at point A, for the example, point B, or in this case we took, like, for the example, at point P. Alright, point P. But the acceleration of the body remain at G, right? It doesn't change. A is there, so you have AY for the example, or AGY. You have AX for the example. Doesn't matter, the direction of A doesn't matter. Maybe in this direction, AX, maybe in this direction, negative AX, doesn't matter. But A must be referred to point G. So instead of point G, you get summation of moment at point P. At point P. So it is equal to summation of moment due to kinetic. Just previously, when you choose point P, A is not considered. The acceleration is not considered because A is on point G. But now you see that A not start at, you are referring to point P, right? And then A is not starting from point P. It start at point G. It's remain at point G. So instead of equal to Ig alpha, now your equations change to summation of moment at P is equal to summation of moment at, so summation of kinetics elements at point G. Or sometime you can see that in some pages you write it is written in this form, Ig plus, okay, or sometimes written in this form. Okay, so what's the difference? Okay, we don't want to find the difference, but we want to find what's the similarity. Why this one is different? Yeah. So sometimes you will find the equation or summation of moment at P is equal to this one is in a problem, sometimes in this form. Basically, it will give you the same answers lah. Alright. Okay. And then what I'm going to tell you is, so from what I'm going to tell you is, from this equation of motion for translational motion, which is this one, and for rotational motion is this one. So this one is not specific, and this one is not specific to rotational motion. All the equation that we have discussed just now can be used for translational motions problem or rotational motion problems, and it can be used in what we call it general plane motion. So what we can summarize here, those three equation or four equation, summation of fx is equal to m agx, summation of fy is m agy, and then you have another one, that we have discussed just now. IG alpha, or you can write it is summation of moment at point P. So, or any point, or any point is equal to summation of kinetic element at point P. So basically, this is very useful to solve problem in a translational rotation, all involved, and general plane motion. Right? So we have to go through every single subtopic after this, and then we discuss the related problems. Okay. Thank you very much. I think we have to discuss equation of motion specifically for translation in next video.